Right now, without you noticing, a single speck of light is landing on your eye. It has been traveling for so long that when it first set out, the Earth did not exist yet. No sun, no you, only a young universe, and one impossibly bright thing throwing this light out into the dark. That thing has a name, Ton 618. And you have probably heard it called the largest black hole in the universe. That is almost true. And tonight, the almost is the whole story. By the end, you will understand 3 things that catch almost everyone off guard. How do you weigh something you can never see? Why is even the word largest still argued over? And what is the one detail buried in all of this that genuinely unsettles the people who study Ton 618 for a living? So let us start somewhere you can actually stand. Not out there in the deep past. Right here with something you already know by heart. The sun. Wide enough to pour 1,000,000 Earths inside and still leave room to spare. And its light, moving at the fastest speed this universe allows, still takes 8 long minutes just to reach you. Now drift outward, past Mars, past Jupiter, all the way to Neptune, the last real outpost before the dark. Out here, the sun is only a bright star, and the whole solar system already feels far too big to hold in your head. Hold on to that feeling. You are going to need it. To give that a shape, Voyager, our fastest, farthest traveler, has been flying for almost 50 years, and it is only now slipping past the edge of the sun's reach. 50 years of flight, just to leave our own front porch. Now hold that entire picture in your mind. Every planet. Voyager's 50-year journey, all of it. Because here's the strange truth. Ton 618, all on its own, is about to make the whole thing look like a rounding error. Drop this black hole where the sun sits, and its edge, the point where nothing, not even light, can turn back, would swallow Neptune's entire orbit more than 40 times over. Light itself, that fastest thing in the universe, would need about 2 weeks simply to cross it. 2 weeks. To pass a single object. Stand anywhere near a thing like that, and it would not look like a hole at all. It would look like a wall. A curved horizon of pure black, swallowing half the sky, so wide that a beam skimming its edge would be older than all of human history before it ever reached you. Sit with that for a moment, and here's the strange gift hidden inside a number this large. Next to it, the things pressing on you tonight, the deadline, the argument, the worry you carried to bed, quietly lose a little of their weight. You are allowed to feel small here. It turns out to be a kind of relief. But size is only half of what makes this thing a monster. The other half is violence. Picture whole stars, torn apart and dragged toward the edge, packed so tight and moving so fast that the gas heats up and begins to scream with light. Not a gentle glow. A furnace hot enough to shine across the entire visible universe. We have a name for a black hole caught mid-meal like this. We call it a quasar. And Ton 618 is not just any quasar. Its core alone burns with the light of 140 trillion suns. It outshines every star in a galaxy like our own, thousands of times over. And it does that from a single point barely bigger than our solar system. Some of that fury even escapes as jets, beams of matter flung outward at nearly the speed of light. And all that brightness did something sneaky. It hid the monster in plain sight. Back in 1957, at a quiet observatory in Mexico, astronomers photographed a faint blue dot and simply moved on. They filed it as an ordinary star inside our own galaxy, entry number 618, and forgot about it. It looked so unremarkable that nobody, not one of them, thought to ask how far away it really was. For 13 years, one of the most extreme objects in the entire universe sat mislabeled in a drawer, wearing the wrong name, waiting for someone to look again. Then, in 1970, its radio glow gave it away. An astronomer named Marie Helene Ulrich turned to read its light properly, spreading it out into a spectrum, the barcode hidden inside every beam of light. And what Ulrich saw did not belong to any ordinary star. Every line in that barcode was shifted, dragged far toward the red end of the spectrum. And that shift is a distance. The more stretched the light, the farther it has traveled, and the deeper into the past you are seeing. This faint blue dot was not a nearby star at all. It was a giant, roaring at us from more than 10 billion years away. Which brings us to the first thing I promised you. How do you weigh a giant you can never visit, never touch, never even truly see? You cannot put a black hole on a scale, so you do something cleverer instead. You watch its grip. Clouds of gas whirl around the black hole like water circling a drain, though unlike water, nothing that slips over the edge ever climbs back out. And here is the key. The heavier the black hole, the harder its gravity yanks, and the faster that gas is flung. So measure how fast the gas is moving, measure how far out it sits, and gravity fills in the rest. It is the very same law that keeps a planet in its orbit, just scaled up past anything else we know. There is even a way to map the distance directly. When the quasar flickers, the gas clouds around it light up a little later, echoing the change. Time that echo, and you have measured a gap across space you could never hope to cross. It is a kind of radar built from patience and light. Do all of that, run the numbers, and out comes a figure so large it is almost meaningless. 66 billion times the mass of our sun. But here's the part that usually gets skipped straight past. That number is not a measurement. It is an estimate. Ton 618 is simply too far to weigh directly, so everything is inferred, layer upon careful layer. And when a different team read the same light in a different way, they came back with a smaller answer, closer to 40 billion suns, still monstrous, but a full third lighter. So which one is right? Honestly, we do not fully know. And that should feel frustrating. Somehow, it does the opposite. You are watching human beings stand at the very edge of what they can know, admit it plainly, out loud, and keep going anyway, reading the weight of a giant off nothing but a faint whisper of ancient light. There is something genuinely hopeful in that. And that uncertainty leads somewhere uncomfortable. Because if the number itself can wobble by tens of billions of suns, then that one proud word, largest, might not even be true. Take a black hole in a galaxy called Holmberg 15A, far closer to home, close enough that we can watch real stars swing around it and clock their speed directly, the way you would time a runner on a track. No distant guesswork. No inference stacked on inference. This is the gold standard, a direct measurement. and Holmberg 15A weighs in at around 22 billion suns, smaller on paper, but pinned down with far more confidence. So who truly deserves the crown? The distant giant we can only estimate, or the nearer one we can actually weigh? And then, just to make the whole thing messier, there is Phoenix A, which on some charts towers over both of them, somewhere near 100 billion suns. But hold on. That Phoenix number does not come from watching anything move. It comes from a model, an educated guess about how the galaxy and its black hole grew up together. Impressive, but a long way from proof, and plenty of astronomers treat it with real caution. So here's the honest headline. Ton 618 is the largest black hole we can confidently estimate, at least from the early universe. Not the undisputed champion of them all. And somehow, that messy, argued over truth is far more interesting than a tidy world record could ever be. And Ton 618 is almost certainly not alone. It is simply one of the brightest, and therefore easiest, of a hidden population. For every giant we have managed to catch, there are surely others, just as vast, whose light is too faint or too far for us to have noticed yet. We are not looking at the biggest thing out there. We are looking at the biggest thing we have happened to see. But size, in the end, was never the detail that truly unsettles the people who study Ton 618. I promised you there was one that does. And it has nothing to do with how big it is. It is how old. Remember that stretched, red-shifted light, the giant roaring from 10 billion years away? That distance is also a clock. So you are not seeing Ton 618 as it is. You are seeing it as it was, back when the universe itself was barely 3 billion years into existence. Cosmically speaking, almost newborn. And that turns out to be a genuine problem. Because black holes are supposed to grow slowly, feeding gram by gram over unimaginable stretches of time. Yet here is one already, 66 billion times the mass of the Sun, fully grown, sitting fully formed in an era that should have been far too young to build it. By everything we thought we understood, it should not exist yet. And there it is, blazing away in the early dark. And it is worse than just a tight schedule. A feeding black hole fights itself. The brighter it burns, the harder its own light pushes the next meal away, a natural speed limit on how fast it can grow. To reach this size this early, Ton 618 had to somehow race past that limit, again and again, for billions of years. So how do you build something that enormous, that fast? Nobody is certain. Maybe it never started small at all. Maybe giant clouds of gas collapsed straight into massive seeds, skipping the slow beginning entirely. Or maybe these early black holes simply found a way to feed harder and for far longer than we thought was possible. Both ideas are still just hypotheses, and careful scientists label them exactly that way. And this is not an old, settled argument. Right now, our newest telescopes are staring into that early universe, and they keep finding more of these things, black holes that look far too big, far too soon. The early cosmos, it seems, was far better at building giants than our finest models ever expected. Ton 618 was not a freak. It may have been a warning that we are missing something. And here's the thought I keep circling back to. Everything you have just watched is, in a sense, a ghost. That light, the very speck that started us off, left Ton 618 more than 10 billion years ago. What you have been looking at this entire time is the deep past. In all the time since that light set out, the real Ton 618 has kept feeding, kept growing, becoming something our telescopes have not caught up to yet, and maybe never will. So the monster you met tonight is really a memory. You have spent these minutes gazing at the portrait of a giant, painted in light, sent across the dark, from a universe that has already moved on without us. So, can we truly weigh a thing we can never see? Yes. Carefully, honestly, and never quite perfectly. Is Ton 618 the largest black hole in the universe? Almost. And is that almost a failure? No. That small, honest almost was the whole story, exactly like I promised, and it is the most human thing about the science. So where does a thing this vast leave you, sitting there tonight? Here it is. You are one person on one pale little world, circling one ordinary star who just reached across 10 billion years of space to weigh a giant you will never touch and understood it. That you can even try from here is its own kind of wonder. So whatever is waiting for you tomorrow, let it sit a little lighter tonight, measured just once against all of this. If you want to keep looking up with us, this is one chapter in a whole series on the true giants of the cosmos. The full playlist is right here on screen, and the next video is one tap away. No hype, no rush. Just stay curious and subscribe if you want to keep exploring. I will see you out there among the stars.